transformations of functions. And one thing that I use to help me remember how to do this is the following. If it's outside, it's vertical and in the same direction. And if it's inside, it's horizontal and in the opposite direction. Okay, that might not make much sense for you right now, but if you look at this, start looking at this right here. So this f of x plus 3, the plus 3 is outside. So it's outside. So that's vertical in the same direction. So plus is up. That's going to be up. Okay, so that's outside. And let me make this a different color. So this is inside right here. F of x plus 3, that's inside. And it's a plus. So you would normally think the plus is going to the right. But here, since it's inside, it's the opposite. So it's going to the left by 3 units. Okay, over here, we have f of x minus 2. The minus 2 is outside. So that's down. Minus is down. Plus is up. This one is inside. It's minus 2. Minus, you would normally think, oh, that's to the left. But no, that's to the right. Because why? Because this is inside. Inside. Okay. Another thing is reflections. So this minus sign, so notice this minus sign here is outside. The minus sign is outside. This minus sign is inside. Okay. So reflection is when you have a minus sign like that, and it's just going to be a vertical reflection because it's outside, so it's vertical. And when you're vertical, that means you're reflecting this way through the x-axis. Okay, so that's through the x-axis because it's vertical. And then this is horizontal because it's inside, and so that's reflecting through the y-axis. Okay, so even though the y-axis is sort of like y values represent the vertical, right? But the y-axis is reflecting through the y-axis. That's a horizontal reflection. Okay. Number 4, we have a graph of a function f. So this is the original f, and we want to match each equation with the labels. So these are just some various transformations. So this plus 2, that's outside, so it's going to shift it up by 2. And so you look at which one's up by 2, and it's this number 2 right there. Okay. This one is inside. So that means it's horizontal, and that's going to go left by 3. Horizontal and in the opposite direction, so left by 3. So that's going to be this one right here. Okay, this one is inside. And so it goes in the opposite direction. That's right by 2. That's going to be this one. And then finally, we have this one. This is outside. So that's going to be down. So that means it's vertical, down 4. And that's going to be this one. Because that's been shifted down by 4. 1, 2, 3, 4. That point went down 4. Everything went down 4. Okay, so that's an example right there, number 5. Even and odd functions. Okay, so even, that means that f of negative x is equal to f of x. That's how you can tell a function is even. It's like, for example, an example would be f of x equals x squared plus 3. F of negative x is equal to You replace this all the x's here with negative x's. But when you square this, you're going to get the original back. So you're going to end up with the original function back. Okay, so that's equal to that. And this one, the graph's going to look like this. And it's symmetric with respect to the y-axis. And all even functions are symmetric with respect to the y-axis. That's going to be this answer here. Odd functions have the property that are defined this way. So f of negative x is equal to negative f of x. And an example would be x cubed. Let me call it g. So g of negative x is negative x to the third power. You take a negative number to the third power, then you get negative. So negative 1 to the third power is negative 1. So this is going to be negative x cubed, which is equal to the negative of the, here's the original. This is the negative. This is the original. This is the negative of it. Okay, by putting a negative in there, you get the negative of the original. And the graph looks something like this. So this is actually symmetric with respect to the origin. So that's another way to tell even or odd, whether our function is even or odd. Okay, moving along to number 7. Describe how the graph of each of the functions can be obtained from the graph of f. Okay, so here we start with this one right here. So you start with this inside part, and then go to this outside part here. So you start with inside. This is inside, so it's a horizontal, and it's minus, so that means it's going to move it to the right by 3. And then this part is going to be up by 2. Plus 2 is outside, that's vertical, and it's in the same direction. So plus is up and minus is down. So the answer would be shift 3 units to the right, and then 2 units upward. So this answer here. Okay, 3 units to the right, and then 2 up. Let's see this one right here. That's going to be left by 4, and that's going to be down 1, because this is inside, that's outside. So left 4, and down 1. So that'll be this answer here. Okay, now this brings us to another something that happens. Okay, so here they have a 3x. Okay, so the multiplying by 3 has a different effect. It doesn't shift it. Multiplying by 3 is either going to shrink it or stretch it. Now this is inside, so that means it's horizontal, and it means the opposite. Okay, so multiplying by 3 is actually going to, that means it's going to be shrink horizontally by 1/3. Okay, so so multiplying by 3 is actually shrinks it horizontally by 1/3. Okay, so that's going to be this one right here. In contrast, this is also inside. Again, it's horizontal and opposite, but this is going to be stretched horizontally by 3, by a factor of 3. Okay, so that's going to be this answer here. Okay, because it's inside. Okay, now this is all theoretical. Let's look at some actual examples of functions. Explain how each graph is obtained from the graph of f. So the first one, this -3 is inside. So, and it's subtracting 3. That means it's a shift right. Okay, so minus is going to be, it's not going to the left, it's going to the right because it's inside. So that's going to be shift right by 3. Here, this is outside. So that's going to be down 3. So shifting it down 3. If you guys have any questions, just let me know, okay? Just stop in and let me know. Okay, number 10. Use the graph of y equals the square root of x to graph the following in red. Okay, so this right here, this -1 is inside. That means it's going to go right by 3. Now the original graph, y equals the square root of x, it looks like that. I guess they're dotted in blue. So you want to look for the one that's been shifted to the right, and this one right here has been shifted to the right. Okay, that's been shifted to the right by 1. So by 1. By 1. That's a 1 there, not a 3. Okay, so that's going to be the bottom right one. Okay, now the next part of that problem. Here we have, this is outside. That's going to be up 5. It's going to shift it up by 5. So this one right here. Okay, next part. This is inside. So it's gonna go left 1. That's outside though. That's gonna go up by 1. So left 1 and up 1. Like this. So left 1 and up 1. This one right here. Because that's where that is. From here to here, it's left 1 and up 1. And then part D, the last part of this one. Here, this minus is outside. So that's going to be reflect through the x-axis. Okay, and then this is outside also, so that's going to be up 5. Okay, so reflect through the, so basically what's going to happen is you have, this is the original one. And so you're going to reflect that through the x-axis because this is outside, so reflect through the x-axis right here. So it's gonna, instead of going up like that, it's gonna be coming down like that. And then you're gonna shift that up by 5. Okay, so you're gonna end up with this one right here. You're gonna end up with that right there. So reflect that and then shift and then pull it up by 5, up by 5. Okay. Okay, so here, number 11, the graph of y equals absolute value of x is just right here, like that. It branches out from the origin, okay? Okay, that's y equals absolute value of x. Okay, and so what they want us to do is graph these functions. So first of all, it's negative x. So this negative is outside. So it's reflect through the x-axis. Okay, so all this goes down, and this stays the same, so it's going to be like that. Okay, so it'll be this answer here. Okay, let's move on to the next one. Okay, here, both of these are outside. So you have a negative sign. The negative will reflect it through the x-axis. And the 2 will stretch it vertically by a factor of 2. Okay, so you end up with that. So this right here looks like it's just been reflected, and this has been stretched. Okay, by stretch, basically what happens is you take whatever value you're at and you double it. Okay, because the factor is 2, so that means you double this distance here. You double it, and you get a point there. This distance is 0, so it stays the same. So essentially, you double all these distances. Double that distance, and so on. Okay, that's why you get something like this. That's what the stretch is. If it's a factor of 2, it's a factor of 3, then you triple all the distances, or etc. Okay, number 13. The original y equals x squared. That's just a parabola that opens up from the origin, right? Okay, this part is going to move it left by, because it's inside, that's going to be left by 2. This is outside, so it's going to be up 1. The plus 1's outside, so it's up 1. Okay, I made a mistake. Minus means it's going to go right by 2. If it's inside, that's going to go right 2. So right 2 and up 1. So you imagine this moving to the right by 2 and up 1, and you would get this right here. Okay, so that's been shifted to the right by 2 and up 1. Okay, so great, that's number 13. Number 14. Okay, so number 14, we have this original function, y equals the cube root of x. If the graph is shifted 3 units to the right, what is the final transform graph? Okay, so 3 units to the right would be, it's going to be inside. So this is right and left is horizontal, so that's going to be inside. And since it's 3 units to the right, then you need -3. Okay, so you replace the x with an x -3, and that will do it. Okay, so it's just kind of going backwards. Graphs of f and g are given. Find the formula for the function g. Okay, so this blue graph is y equals the absolute value of x. Okay, this has been shifted up by 4. No, up by 5. Yeah, because this is 5. So that's been shifted up by 5. And then it's been shifted left by 1. Okay, so to go up by 5, it's going to be a +5. You know that I want that on the outside. To go left, you're going to have a +1 in the inside. Okay, so you start with absolute value. Okay, so you start with f of x equals absolute value of x, and this x is inside, so you put a +1 in there. Okay, and now I'll give you, this will move you, this +1 will move you to the left by 1. The +5 will move you up by 5. Okay, so that should give you the answer. Okay, let's look at number 16. And we're supposed to determine whether these are even, odd, or neither. So that function right there. So the criteria is even means that this is going to be the original function. Odd means this is going to be the negative of the original function. It could also be neither. So we'll go ahead and calculate that. F of x is x squared plus x. So you replace this x gets replaced with a negative x. So replace those two with negative x's. Like that. And this becomes x squared, and that becomes minus x. Okay, so now if you're looking at it from the other end, a negative f of x is equal to negative x squared minus x, and then f of x equals x squared plus x, right? Okay, this one is not equal to that one because this one has a minus right here, this doesn't. And this one is not equal to that one either because this has a minus here and that doesn't. This has a plus. Okay, so in this case, it's neither. And then we're going to tell which graph it is. We have these three. Well, this is a parabola because the highest order term is x squared, so it's a quadratic, so it's a quadratic polynomial. So this is a parabola is the graph. So it's going to be one of these three here. You could take, I guess the easiest way to figure out which one it is to take this x squared plus x and set it equal to 0 and find the zeros. So x equals 0 or x equals -1. So that means that it's going to cross the y-axis at 0 and at -1. Okay, this crosses at 0 and 1, so that can't be it. This crosses only at 0. This one crosses at 0 and also -1, so it has to be this one. And we'll give you better ways of figuring out which one it is, by the way, in the future. You can also use GeoGebra to graph it if you want, and that will quickly give you the answer. Okay, number 17. Determine if this function is even, odd, or neither. Okay, so if we take f of -x this time, we replace these x's with negative x's, right? And then this is going to be negative x cubed plus x. Okay, now we're going to compare this with f of x. This one is not equal to that one because this has a minus here, that doesn't. This has a plus, this doesn't. This has a minus. Okay, negative f of x is the negative of this, so negative x cubed, and the negative of that is plus x, and that's equal to that one. Okay, so this one is equal to negative, these are equal, okay, because negative x cubed, x plus x plus x. So these are equal, that means it's odd. That implies it's odd, okay? So you have an odd function. And for the graph, probably, again, the easiest way is to see where Okay, just have that equal to 0, and see what happens. This is a cubic, so it's going to look like one of these. It's not going to look like a quadratic like that one. So you can rule that out. But maybe the easiest way is to figure out where it crosses the x-axis for this problem. You know, other problems might have a better, easier way, or worse, or not a very easy way to do it. You can always fall back and go and use GeoGebra. So if you factor that all out, you get x equals 0, x equals 1, and x equals -1. That means that it has to go through 0 and -1 and 1. Okay, this only goes through 0. This only goes through 0. This one goes through -1, 0, and 1. So this has to be it. Okay, the bottom right.